Hello, everyone. This is Dr. Vaughn, and I'm going to give you a brief guidance and tutorial on this week's material, which we're doing confidence intervals and hypothesis testing on variances as opposed to means. So last week we looked at mostly tests on the means, proportions and means, the proportion of people that voted one way or the other, the average about something. This time we're going to look at confidence intervals and hypothesis testing on the variances or the standard deviations. They're pretty much the same, the standard deviation being the square root of the variance. What I have pulled up here is the template, Excel template, right from your MindTap. This is activity 1A in 11.1. So this is actually one of your activities. Here we're actually using just the given data as an example of how to do this point estimate for the sample standard deviation and then the confidence interval for the population standard deviation. I thought it would be a good example to work through. So you have your data over here on the left. This is the dollars spent on Halloween costumes, and we're supposed to compute the mean, the standard deviation, the degrees of freedom, the cutoff values for the critical chi-squared value. We'll talk about that, and then the confidence interval itself. And this ultimately are going to be the numbers that we'll put back into Cengage MindTap as a result, to complete our assignment. I've also pulled up the help video, which are very helpful tutorials. So if you walk through these, they'll tell you exactly what to do. The data will be a little bit different. And so I would suggest that you kind of keep these open and go back and forth, pause it, fast forward to the part that you need to work on. And so let me get you caught up to what they've done in this video, and then maybe we'll jump down to this. This is the really difficult part, the lower limit of the chi-squared and the upper limit of the chi-squared. We'll spend a little bit of time on that, and then we'll look at the formula for the confidence interval itself, which is mostly just putting these pieces together with a simple formula down here. So let's take a look at that. First of all, on the mean, we're going to go to the green box over here, and we're going to use the average command for the mean average. And you can do, as they tell you in the video, do A colon A, which will do all the data, but not the label in A. You can also just click on the column itself, and it'll do that A colon A, and then close parentheses. So all I've got to do is type it in there with the equals, and then it'll compute it, and then it's automatically typing the formula over here for you to see. Standard deviation, we're going to use equals stdev.s, the sample standard deviation, parentheses, and again, click on the column A and close parentheses. So there's our sample standard deviation. The degrees of freedom is going to equal n minus 1. So in this case, I think that because the box is blue, I can just type the number. There are from 2 down to 17. So there's 16 data items here, which means we're going to have 15 degrees of freedom. Now, I think that let's check the video, because I think if we go back to where they do the degrees of freedom, let's just kind of fast forward to that.
.right function can be used to compute the critical chi-square value formula, the n minus 1 count. Yeah. Counting all the numeric values in column A colon A, close.
Right, so instead of manually counting this, they actually want to use the Excel function, which is the count, and then parentheses, and again, the column, all the things that are in column A, just the data values, and then you'll get that 16. But now I need to go back and do that minus 1 to get your degrees of freedom, which is the 15. It's the n minus 1 for degrees of freedom. And then we'll go to the lower limit critical chi-squared area. Let's go back to the video.
Associated degrees of freedom using in cell D10, type equal chi-square period, locate the INV right function, choose the probability of 0.025, comma, the degrees of freedom in D8.
All right, so let's do that on ours. We're going to use the chi-squared in RT, and let's talk about where they get that 0.25 from. Right, so equals chi-squared. You just type the first few characters. You find the one that you want. You right-click on it, and now I need to put in that probability. Where does that 0.25? Let's go back and look at the problem statement itself. We're doing this 95% confidence interval. So in a 95% confidence interval, you have two 5% tails. And so you take that 5% alpha value, the part that's outside of the confidence interval, that 5%, and you divide it by 2, because there's two different areas you could be outside of that confidence interval. So you take the 5% and divide by 2, and that's where the 0.025 comes from. I'm going to enter that 0.025 as the size of one of the tails, the probability, and then comma, and then I want the degrees of freedom. And I can just do a cell reference to D6 because I've already calculated the degrees of freedom, and then close parentheses. And that gives me that lower, notice there's kind of, it seems backwards here. The lower limit is the right tail, and the upper limit is going to be the left tail. So I'm going to do the equals chi-squared dot inv without the RT, just the chi-squared dot inv. And again, I'll put that 0.025 and then comma, the degrees of freedom. And that's how I'll get my lower and upper limits on my critical chi-square values. And then finally, I want to build this 95% confidence interval. All right, let's go back to the video.
Limit.
Kind of fast forward. We'll find the part where she's kind of looking at that. And what you'll see is this kind of formula,
square root D8, or the degrees of freedom,
which is right here on the screen, and she's just basically typing this formula into our Excel. So I'm going to pause this for a minute. I wish I could move this little text box out of the way. Let's just go with it.
Divide that.
You're going to have D8, which is the degrees of freedom, times D5, which is the standard deviation squared, S squared, that's the variance, and then divide by D10, which is the lower limit for the lower limit. All right, sorry, I won't talk over that video anymore. Let's go back over here and do it. For the first one, we're going to do square root, parentheses, the degrees of freedom, times S, which is the sample standard deviation, squared, so up caret, shift 6, 2, and divide by the lower limit chi-squared value, and close parentheses. And then on the upper limit, we'll do the same thing, equals the degree square root, the degrees of freedom, times the standard deviation squared, so the variance, divided by the upper limit, and close parentheses for the square root. So my lower and upper limits of the confidence interval, 17.45, 36.55. Let's see how I did. So I'm going to take these values now and go type them into MindTap. What's the point estimate of the population mean? Okay, so that was 40.56. What's the sample standard deviation? That was 23.62. And the 95% confidence interval from 17.45 up to 36.55. And you can see I checked my work, I got them all correct. That's how you do your first confidence interval. When we go to do hypothesis testing instead of confidence intervals, we're going to use these same kind of formulas for the critical values that are going to determine whether we accept or reject the null hypothesis. So we'll do very similar kinds of things with this chi-squared distribution as being the distribution on the sampling distribution of the standard deviation. In our point, our point estimate will be the observed sample standard deviation and our hypothesized standard deviation, and then we have these critical values, and then you have this formula that involves the square root in order to find that standard error term on the sampling distribution for the standard deviation. All right, I hope this has been a little helpful. Welcome to week 3, and I look forward to putting out a little bit more content in the next couple of days. Have a great week.